Imagine flying miles away from your house into a vast, sprawling forest with no map, no phone, and no street signs to guide you. For a tiny honeybee, this isn't a terrifying ordeal, it is just a typical Tuesday morning spent searching for the perfect patch of flowers. These incredible insects can travel long distances to find nectar and then return to their hive with pinpoint accuracy every single time. It is a feat of navigation that seems impossible given the size of their tiny brains and the complexity of the world around them. However, bees aren't just guessing their way through the air, they are using a sophisticated suite of biological tools that rival our modern GPS systems. Today on Behind the Basics, we are breaking down the incredible science of how bees find their way home. We will explore the secret compasses and hidden maps they use to navigate. Let's get into it. The world of the hive is waiting to be discovered. To understand how a bee navigates, we first have to look at their primary tool, the sun. Bees use the sun as a solar compass, allowing them to maintain a steady heading even when they are flying in unfamiliar territory. But what happens if it is a cloudy day and the sun is hidden from view? This is where their biology gets truly high-tech, as bees can actually see polarized light through the clouds. This allows them to determine the sun's exact position even when we humans can only see a gray, overcast sky. Furthermore, bees have an internal biological clock that accounts for the sun's movement across the sky throughout the day. If a bee spends several hours at a flower patch, it knows exactly how much the sun has shifted and adjusts its flight path accordingly to stay on course. This time-compensated sun compass is a marvel of evolution that ensures they never lose their way due to the passage of time. But the sun isn't the only thing they rely on, they also keep a running tally of how far they have traveled. By measuring the optic flow, or the speed at which the landscape moves past their eyes, they can calculate the exact distance from the hive. This combination of direction and distance allows them to create a mental vector that points directly back to their home base. It is a mathematical approach to flight that keeps the colony fed and thriving. Every flight is a calculated mission. By integrating these different data points, the bee maintains a perfect sense of its position in three-dimensional space at all times. They are masters of the sky. Every grain of data matters for their survival. They never stop calculating their next move. Once a bee gets closer to the hive, it switches from long-range solar navigation to short-range landmark recognition. Just like you might recognize a specific red house or a large oak tree on your street, bees memorize distinct features in the landscape. They take orientation flights when they are young to photograph the area around the hive with their compound eyes. This creates a library of visual markers that they can use to fine-tune their approach as they get within a few hundred meters of home. However, visual cues aren't the only way they recognize their specific colony among dozens of identical-looking boxes. Every hive has a unique scent signature created by the pheromones of the queen and the specific flowers the colony has been visiting. Bees use their powerful antennae to pick up these chemical signals from the air, guiding them to the correct entrance even in a crowded apiary. This multisensory approach, using light, distance, landmarks, and smell, makes their navigation system incredibly robust and difficult to disrupt. Even if one sense is hindered, the others can usually compensate to bring the bee home safely. This redundancy is vital for the survival of the hive, as a lost bee is a lost worker for the entire community. Scientists are still studying how such a small nervous system can process all this complex data so efficiently and quickly. It challenges our understanding of what simple creatures are actually capable of achieving in the wild. We are constantly finding new layers of complexity in their behavior. The more we look, the more we realize that bees are some of the most sophisticated navigators on the planet. Their survival depends on this perfection. This biological precision ensures that the entire colony remains productive and safe. Their dedication to the flight path is a marvel of the natural world. But the most famous part of bee navigation isn't just how they find their way home, it's how they tell their friends where to go. This is known as the Waggle Dance. When a scout bee finds a great source of food, she returns to the hive and performs a specific series of movements on the honeycomb. The angle of her dance relative to the vertical line of the hive tells the other bees the direction of the food relative to the sun. The duration of the central waggle part of the dance tells them exactly how far away the flowers are located. It is essentially a living map. The other bees watch the dance, feel the vibrations with their legs, and then fly out to the exact spot described by the scout. This level of symbolic communication is extremely rare in the animal kingdom and allows the hive to coordinate its efforts with massive efficiency. By sharing their personal navigation data with the rest of the group, a single bee can mobilize hundreds of others to a rich food source within minutes. It is the ultimate example of teamwork driven by high-level biological mathematics and precise spatial awareness. So, the next time you see a bee buzzing around your garden, remember that it is performing a complex series of calculations just to stay on track. From tracking the sun through the clouds to measuring the flow of the landscape and dancing out directions for its sisters, the honeybee is a tiny master of physics and geometry. Its ability to find its way home across miles of terrain is a testament to the power of evolution and the complexity of the natural world. Behind the simple sight of a bee on a flower is a high-tech navigation system that has been perfected over millions of years. It reminds us that even the smallest creatures have incredible stories to tell if we just take the time to look closer. The hive is a hub of pure scientific wonder. The navigation of bees is a perfect example of how nature solves complex problems with elegant solutions. If you found this breakdown of bee science fascinating, please hit the like button and subscribe to Behind the Basics. We have many more deep dives into the hidden world around you coming up very soon. Thanks for watching, and stay curious until next time. We can't wait to share our next discovery with you. Every journey starts with a single flight. Their tiny brains prove that size doesn't limit intelligence. Nature truly is the ultimate engineer.